Hello, today we'll be taking a look at Leetcode problem 3085, minimum deletions to make string k special. In this question, we're given a string word and an integer k, and we're asked to return the minimum number of characters that we need to delete in order to make word k special. By k special, we mean that the absolute difference between the frequency of any two characters in word is less than or equal to k. Or another way to think about it is that the frequency of the most frequent character in word minus the frequency of the least frequent character in word is less than or equal to k. So how can we solve this? Well, an initial thought might be to just go with a greedy approach and focus on deleting the current most frequent character using, say, like a heap. But there's a caveat, and that is we're allowed to delete the entirety of a character from word and therefore removing it from consideration. So let's take a look at example 1. If we went with the greedy approach, we will be deleting, well, 3 A's and then 1 B, since k equals to 0. That'll be 4 total deletions. But if we instead deleted every occurrence of C, that's just 1 deletion, we're left with 2 B's and 4 A's. And we just need to delete 2 more A's for a total of 3 deletions. So how can we come up with a solution that accounts for this special case as well? An observation that we should make here is that the final k special word that is optimal, it has a base character. And what do I mean by base character? The base character of our final word is the character with the least frequency in the final word. And so any character from the original word that has a frequency less than our base character, the frequency of our base character has to be deleted entirely. And for any character in the original word that has more frequent than our base character, we check the difference between their frequencies is less than or equal to k to ensure that the k special criteria is met. So what do I mean by this? Going back to example 1, in the optimal solution, our base character is b, and so b has a frequency of 2. We see that in the original word, C has a frequency of 1, which is less than B. Therefore, C, if we chose B as the base character, C cannot exist in the final word. So, because it cannot be less frequent than our base character, so we delete C entirely. And we see there's 4 A's, which is 2 more than the number of B's we have. So we need to delete that 2 extra, and for a total of 3 deletions. And with this in mind, the solution will be to iterate through all of the unique characters in Word and see if I chose this character as the base character, how much deletions do I need to make? And the best solution will be the deletions we had to make that's minimum if we chose a particular out of all these possible base characters. And so let's quickly write a solution for this approach. Well, first and foremost, we need to count the frequency of every character in Word, and we could do this using like a dictionary or a hash map. Okay. And for every character in Word, the frequency of that character, let's just increment it by 1. So after this loop, we'll have the frequency of every character in Word. And for the character and frequency in Word, and for every other character, so this outer loop here, we're essentially picking C as our base character, or like trying to pick C as our base character, and we're iterating through every other characters in our word. If the current character is equal to our base character, we don't have to do anything because they're the same. Elsewise, if the current frequency is less than the frequency of the base character, then it cannot exist in the final solution or the final word. It cannot be less frequent than the base character. We had to delete all of it. Let's have a variable to keep track of our total deletions. Just say 0 for now. And if this is the case, we say we're going to delete all of the current character, which is F2 occurrences. Continue. Elsewise, if we reach here, we know that the frequency of the current character is either greater than or equal to the frequency of the base character. So the total number of deletions we need is going to be f2, which is the current frequency, minus f, the frequency of the base, and note that we have the padding of k. So another thing to note that is this deletion could potentially be negative, right? If k is pretty huge and f2 minus f is less than k, then that totally deletions could be negative, but we don't want to take a negative deletion count. Is just call it deletions. Total deletions is equal to the max of either deletions, or if it's negative, we just take 0, right? So at the end of the inner loop, we want to also just keep track or update our current minimum deletions. Let's have a top level variable is, well, need an initial value for it. So if we look at the constraint, we see that word.length is less than or equal to 10 to the power 5. So worst case, it wouldn't get worse than 10 to the power 5. Let's put 10 to the power 6 to be safe. And at the end of the inner loop, the minimum deletions is equal to the minimum between the previous minimum deletions or the current total deletions. And let's just return minimum deletions. Right. Let's see errors. Oh, plus equal. We don't want to redeclare total deletions. And yeah, let's just run this and see if we had any others. And min deletion seems like I have a typo. It's right there. Yep, looks good. So what's the runtime of this, right? Like this double for loop right here looks pretty bad. And you might think like, oh no, we're gonna run O of word.length squared, which is pretty bad because it's 10 to the power 5. But we must ask ourselves, what is this frequency, like this freak default dict? It is, well, unique characters mapped to the number of times they occur in word. So how many distinct keys can we have for our like frequency dictionary or frequency hash map? And we look at the constraint and we see that word consists only of lowercase English letters, meaning like frequency can only have 26 distinct keys at most. And if we look at our code in general, or like our overall code, this iteration right here iterates through word, which is O of word.length. And this one is O of 26 at worst. And same thing here. 26. So what is our total runtime? Our total runtime then is going to be O of, well, word.length plus 26 times 26, because these two loops are nested, which isn't that bad at all. And yeah, this is one of the potential solutions for this problem. Thanks for watching.